In this video, I'll introduce the concept of scatterplots, and we'll use them to look for associations between variables. This is the first part of a type of statistical analysis called linear regression. Linear regression is a technique that is used when looking at relationships between two quantitative variables within a single population. However, regression is a powerful tool, and you can actually use it to look for relationships among more than two variables, and the variables don't necessarily need to be quantitative. But we'll start with the basics. Many households have gas stoves in their kitchen for cooking. Recently, researchers found that these stoves emit methane and nitrogen oxides even when they're not turned on. And these gases can lead to respiratory diseases. And it turns out this isn't just an issue with gas stoves. There are many sources of indoor air pollution, and this pollution can be deadly. Thinking about those gas stoves, there are lots of methods people use to cook indoors that could also be harmful to their health. So we might investigate how indoor air pollution affects people's health around the world. In particular, we can look at the percent of all deaths that are caused by indoor air pollution in each country. Here, the dark blue color indicates the lowest percentage, and the yellow color indicates the highest percentage. And we can ask, what factors are related to this percentage? One aspect we might look at is the fuel that people use to cook their food. These fuels range from solid fuels like crop waste, wood, charcoal, and coal, to liquid fuels like kerosene, ethanol, gas, then to natural gas and electricity. And the solid fuels pollute the air the most, while liquids, gases, and electricity pollute the least. So now we can look at the percent of the population of each country that has access to the non-solid cooking fuels. As before, the dark blue indicates low percentages, while the bright yellow indicates higher percentages. Based on the two map colorings we've seen, does it look like there might be a relationship between access to clean cooking fuel and deaths from indoor air pollution? It's hard to see based on these two maps, but we can represent our data using a graph called a scatterplot to help us look for such a relationship. We can start by making a graph that uses the percent of the population with access to clean cooking fuel as its horizontal axis, and the percent of deaths caused by indoor air pollution as its vertical axis. Then, let's think about the first country alphabetically we have information about, in this case, Afghanistan. In Afghanistan, in the year these data were collected, just over 32% of the population had access to clean cooking fuel, and just over 14% of the deaths were caused by indoor air pollution. We can create a point on the graph that represents these two values simultaneously. This point represents the data for Afghanistan. And we can add points on the graph to represent the data for all the other countries too. This type of graph is called a scatterplot. Scatterplots can be useful for identifying patterns in the data. For example, in this scatterplot, you might notice that the data more or less lie along a relatively straight line. This line suggests a negative linear association between the values of these two variables, which is illustrated by these arrows. Specifically, as the percent of population with access to clean cooking fuel increases, the percent of deaths caused by indoor air pollution decreases. Now, there are other variables we could examine to see if there is an association with the percent of deaths caused by indoor air pollution. Perhaps deaths from indoor air pollution could be related to the economic status of individuals and families. So let's consider the percent of the population living below the poverty line. In this scatterplot, you might notice that the data again, more or less, lie along a relatively straight line. However, the pattern is different from in the previous scatterplot. This line suggests a positive association between the values of the two variables, which is illustrated by these arrows. Specifically, as the percent of population living below the poverty line increases, the percent of deaths caused by indoor air pollution also increases. In this scatterplot, you might have noticed that most of the dots were clustered relatively close together, but there was one dot that was far from the others. Although the country represented by this point doesn't have a percentage of deaths from indoor air pollution that is significantly higher than many of the other countries, it does have a percentage living below the poverty line that appears significantly larger than most of the other countries. This is an example of a potential outlier. Now, let's examine some other potential variables. We saw that indoor air pollution deaths were associated with access to clean fuels. Perhaps that access is, in turn, related to the way in which the land is used. So let's consider the percent of land area that is devoted to agriculture. Now, there don't appear to be any noticeable patterns in this scatter plot, so we would say that there appears to be no association between these two variables, or that the two variables are independent. Let's take a look at one more variable. We saw that indoor air pollution deaths were associated with the extent to which individuals were living below the poverty line. Perhaps this has something to do with the overall wealth of the country. So let's look at the per capita gross domestic product, which measures the country's economic output per person. This scatterplot appears to show another negative relationship between the variables. So as the per capita gross domestic product increases, the percent of deaths caused by indoor air pollution decreases. However, unlike before, this association doesn't appear to follow a straight line. So we would describe this as a nonlinear negative association. In this video, you saw how to create scatterplots to help you look for patterns in data. You have to start by selecting your variables carefully. In this video, I selected the variables to demonstrate some different types of associations, but I had to spend a lot of time thinking about how the variables might be related to each other. In the scatterplot, you make one dot per case or element in your sample. In our dataset, each case was a country. Then the horizontal and vertical coordinates of the dot represent the variable values for that case. After creating the scatterplot, you can look for associations between the variables and characterize them in terms of a positive, negative, or no association between the variables. The associations can either be linear or nonlinear, and you can also identify outliers. In upcoming videos, we'll look at how to identify and describe these associations more precisely.